it was announced that Contour 1.12 was released. I don't know if folks are aware, but so Contour is an Ingress controller, or that's what it's best known as. But it doesn't just implement the Ingress resource. It has some resources of its own, one of which is HTTPProxy, which is kind of like an extension of Ingress, we could say. And it, I would say, starts to bring some of the more advanced features you might need to go to something like Istio for, to something that is simpler and more targeted than like the entire workload of Istio. Because there's a lot of things that Istio does, and if all you need is a little bit of extra load balancing rules, then it can be a bit expensive to run all of Istio to get that. So I think Contour does a really good job of kind of bridging that gap and bringing in some of those things. Like here we can see we have support for local rate limiting on HTTP virtual hosts, routes, dynamic request headers, and header hash balancing. So I thought we might install Contour 1.120. Is it 1.12 or 1.120? Either way, I thought we'd go ahead and install that and then just like run through and have a look at what this actually means, like local rate limiting, maybe spin up some resources and do some testing. So here we go. And these are the docs for 1.2.0. That's a good start. Getting started right here. Before you start, you need a Kubernetes cluster. You need kubectl with admin access to that cluster, and your cluster must support RBAC. So this is where I validate I have a cluster. So get nodes. And so this is a 3-node cluster, 3-node TKG cluster. So I can do get clusters. So that's my friend right there. You can see that is fresh as of today, based on that date. And there's nothing installed on here other than the default stuff that comes with a TKG cluster, which isn't a lot, which is a good thing. So basically we're starting from scratch. So we'll go ahead and install Contour. And I assume that this is going to give me, oh, look at this. A Contour operator. Interesting. Should we try and do a Contour operator? Let's see what happens if we do this. We have the time. We have the energy to be trying new and exciting things. So let's go ahead and we won't actually run that. Let's wget this down, wget -o Contour operator.yaml, and that. Right, and so now we can actually have a look at what this looks like. So namespace, CRDs, and then I assume it's going to give us a deployment. No, we're looking for kind deployment just to see what's going on here. Contour. So now I'm pretty happy with what's going on there. We can go ahead and apply that onto our operator. And then we can have a look at what else our doc's telling us. So we've got the operator, and that's going to deploy to this namespace here. So I can do a kn get all. Looks like we are running, so that was pretty quick. And then, so again, we have this command here. And again, we won't actually run it. We will wget this down and then Contour resource.yaml, grab that. And then let's apply it. So kubectl apply dash f to a resource. And then while that's happening, we can have a look at the actual. So here's our contour resource. All right, and this is really simple. So contour sample, network publishing, envoy type node port service. All right. So let's have a look at kgetNS. Oh, here we have project contour, so it must create them all by default in here. Get all. So here we have this. We have node port. We don't have a load balancer. So I guess that's the first thing we need to solve. And this is actually not entirely accurate, because it hasn't given us a service of type load balancer. It's given us a service type of node port. And so Envoy is the actual not load balancer, the reverse proxy, I guess, that Contour manages to create our routes and stuff. And so I'm going to guess that we can change this to load balancer service. And if it doesn't work, we'll look at the docs. And let's reapply this contour resource, and then do a get all. It hasn't changed. Stumbling block number 1 is that. So now we get to explore documentation. Contour Helm chart. No, we don't want that. Where do we find our contour operator? Using the operator. Contour sample. Oh, let's run this. Let's run this. So it says it's available. Our service is still service. Let's just check all namespaces just to verify. Yeah, so there's definitely nothing of type load balancer. And I'm sure this fella right here should be type load balancer. So we need to figure out how we do that. So let's look for this fella right here. Network publishing. Network publishing. So our default is type of load balancing service. And so we actually were told to override that in the resource. And then I guess maybe they haven't done update resources. Let's have a look at contour operator get pods, and then let's do logs of this, and then contour operator. Aha. Update service, how to update service. Invalid resource version must be specified for an update. Wow. Now it did say that this is a experimental or alpha or something. Let's just have a look what the wording was. So I can't get mad if, yeah, look, it says alpha right here. So I can't get mad that it didn't quite work as expected. But I think what I can do is, okay, get contour. Yeah, so okay, delete contour sample. And that should delete it. So let's look at logs. Let's do this. Let's use, I have Stern installed. I don't have logs there. All right, so that looks like it has removed contour sample. All the objects have been deleted. So I should be able to do apply -f into a resource. And then I can look at those logs again. I guess it's created them already. A get ns, a-n, project contour, get all. All right, here we go. We now have a load balancer and we have an external IP. That there is looking much better. Now it'll probably take a minute for this to start working. So why don't we go ahead and make sure we can get an ingress. Just start with a basic ingress resource. And the easiest way to do that, let's do create ns ingress example. CD, come on. ns ingress example. And then I can do something like create deployment image nginx. Let's call it nginx, right? And then we can do a k expose deployment nginx -h. Wait, whoa, that's a lot of yeah. So I want port 80, and is that all I need? Do I need to say type? I think I need to say some type, or there we go, type, and I think I want it to be a cluster IP, and that's the default, right? So I can just do -- port 80, right? So k get so we have an nginx pod that's running, and we have a cluster IP, and so I should be able to do a k port forward nginx 8080 to 80, and I can just background that, right? And then I can do a HTTP localhost 8080. Right, and so that's our nginx working. So now let's go ahead and create an ingress resource. And I'm never good at remembering how kubectl resources work. So let's go ahead and just create a file called well, let's do folder example ingress, and then create a file ingress.yaml, and let's pop back to here and do cd example ingress, and then we can do kget namespace example kget ns ingress.example -o YAML to ns.yaml, kget deployment nginx o YAML to deployment.yaml, and kget service nginx -o YAML to service.yaml, right? So that just kind of gives us a backup of what's running. So there's my deployment, nothing in Ingress yet. There's my namespace, and there's my service. So now we need to fill out Ingress. So let's go to Kubernetes Ingress example. Oh, can I do k create Ingress. Oh, I can do create ingress. Look at this. Oh, this is good. So let's start up here with this and figure our way through it. So I guess we have a name. So let's just call it Nginx because the other ones were called that. I don't know what class is. Rule. Do I want /Nginx equals Nginx, no TLS? Is that what I want? Is that going to work? And I can do dry run. I can do -o YAML. Let's see what we end up with. Ingress name Nginx. Rules. Our host is star. And our paths backend service Nginx port 80, path Nginx, path type exact. I think that's what we were looking for. Let's go ahead and call that. We'll pipe that to ingress.yaml. We'll double. We'll append, not write over it, because it might be useful to keep that comment. And so now we should have whoa. Did it just not refresh? No, it just didn't refresh. All right. So that's done, but because we did dry run, it didn't apply it. So now we can do a k apply ingress. Ooh. All right, so it didn't actually validate that our pathing was right. So let's have a look here. Now, do we need to specify host if we're using path based? I don't know. Let's assume we do. I might have a solution here. Get stash and project contour. Let's just make sure we can look that up. So I think probably we could do a couple of things here. We could use this, or we could grab one of these IPs and use this. I don't know if you're familiar with zip.io, but zip.io is basically like a wildcard DNS responder. So whatever you put before it, it'll respond with that IP. And so I could do this, nginx dot, and it's going to give me that IP address. And as long as that IP address remains correct for this load balancer, this will work. So if we call that, if we roll with that, we can actually just set that as our host. And then I think we can do slash. Let's have a shot at this and see what we get. So we'll do apply again. Still invalid. Path type must be specified. Can I just not do path? Invalid. All right, let's come back to this command here and see if we can sort this out. So rule is now this, and star. Right, let's try this. Right. Oh, I made it worse. I appended. That's all right. I'll just get rid of the original one. Should have realized I was doing that. So there's our host. Path type, so the prefix, I see. Now let's go ahead and do a ingress. So now we have an ingress created. So get ingress. And that is this host here. If I do a HTTP against that, we get my Nginx. So this is Ingress. So this is what we've had up until now with most Ingress controllers, the ability to do some basic rules. So you can see I did the Ingress by host with anything in path. If I remembered, I could have done, I could have used a wildcard here with the right syntax and then sort of like specified by a path instead of specifying by a host. Or maybe I still need to specify host there. And if that's the case, I would have done, let's actually attempt to do that. So if we come back to k-get hn project contour get service. So I think if I had have done, you know what? Let's move on. Let's actually look at the newer features. We've all seen Ingress before. All right, so we're going to call this example good. And then to avoid confusion, we'll see how we go. So next, I guess we have make an example HTTP proxy. And then k create NS example HTTP proxy. Is it 2 P's? Is it 2 P's? Let's have a look. Whoa. Come back to the blog post. I don't want to lose that, so let's pop that over here. But right back to the blog post we started at. Announcing blah, blah, blah. So HTTP proxy. So there is 2 P's, makes sense. So HTTP proxy, yes. And then we'll just change our default namespace to that, and that's using the kubeNS project. And now we have that, we can go ahead and do our k-create deployment, k-create service, k-expose deployment, right, k-get all. Now we can just reuse those names because pods and deployments and services are namespaced. Because I changed namespaces, it's safe to use the same names. So Nginx here is different to the Nginx in the previous example. And that's totally fine to do that because of the different namespace. And as you can see, because I'm using ZSH and Starship, it actually tells me here, this is the namespace I'm on. So that's my Kubernetes cluster. That's the namespace I'm on. So it kind of tells me in the prompt where I am and what I'm doing. So now, can I do k create? This is not going to work, surely. K create. Well, so I was able to do k create ingress, right? Am I able to do HTTP proxy? Okay, I'm not. I didn't think so. But if I did a k explain HTTP proxy, it's actually going to tell me HTTP proxy is an ingress. So kubectl explain is great if you want to have a look at what a resource is and what it looks like. So it's I immediately know that it is a CRD specification and that it has these fields. Now, obviously, I have no idea what a spec is here, right? And I can do -r for recursive. Right, and now, boom, I have like, this is everything that can be in a HTTP proxy, blah, 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 blah. What would be really cool if I could do that, which I can't, but if I could do that and then redirect it to HTTP proxy.yaml and then have like a file I can start editing, that would be pretty amazing. But I don't think we have a good way to do that. Yeah, we don't. Which it would be nice to have something like that, because then even like kubectl create might be able to support doing that. Anyway, we don't have that, but I'm sure we have documentation that's going to tell us what we need. So that's why I kept this open. HTTP proxy fundamentals. Ingress object was added to blah, key HTTP proxy benefits. Yeah, so multi-team Kubernetes clusters. So Ingress isn't super aware of what else is going on in the cluster. So you can actually fight over names and paths, whereas I think with HTTP proxy, it's a lot more aware of other namespaces and other services. Like accepts multiple services within a single route and load balances traffic across them. So that would potentially allow us to have like 2 different versions of an app running and send a percentage of traffic to one versus the other. So, and maybe we can have a look at that. What if we do something like this? So we did a create deployment nginx. What if we do HTTP2? Let's double check on that. Doesn't seem quite right. Docker hub. And we look for, I can never remember if it's HTTP D2 or if it's HTTPD or if it's Apache. So it is HTTPD. I don't really care what version. So we can go ahead and, so it's just HTTPD and we'll just call it, I'm going to call it Apache, just so I know that, so it's clear that that's what I'm running. And then I can do the same for expose, just change it to HTTPD. Oh, really, Paul? You just said you were doing this and then you forget and do it the other way. All right, so now we do a get all. We have Apache and we have nginx. We did a port forward. Did we kill that port forward? We did. Of nginx. We remember what that looks like. Let's do a k port forward of Apache 8080 to 80. Background at HTTP localhost 8080. Actually, can I just do 8080 like that? I think I can. I can. So that's a different message to what we got from Nginx. So we'll definitely be able to tell if it's Nginx or Apache giving us a response. So let's go ahead and kill that port forward. And let's have a look at our documentation here. It might look like that. This object might look like this. So let's go ahead and grab this. And let's create a new file in here called HTTPProxy.yaml. And we will start with this. And we'll call it example. Our virtual host is same as our Ingress-ish. So let's grab that. But we'll just call it web because it may be Apache, it may be Nginx. So prefix, so let's just do Nginx right here. And then I think that is all we need. Example, HTTP proxy, just so it's super clear. You know what? I'm going to call it web because we've got web there. That'll keep things simple in theory. So apply -f HTTP proxy. And then I can do a k get HTTP proxy. And that'll show us this. Status is valid. Valid HTTP. So I don't know what that means. Is it working or is it just valid? Yeah, interesting. So can I run this though? Look at that. That is Nginx. So I think now if I come back here and I copy this and I do Apache and then I reapply that, now there we go. That's our Apache response. That's our Nginx response. That's our Nginx response. Apache. Okay. So now we can do while true, do end. Oh boy. Is it while true, do? Really, Paul? You don't even know how to do a while loop? Is this like Bash amateur hour? You have to Google how to do a while loop in Bash. Come on. While loop, one line. How embarrassment. While true, do foo, done. Isn't that effectively what I did? Do HTTP web. We can leave a sleep in there, right? So Apache, Nginx, Apache. All right. Can I do can I do this? Grep H1. Speed it up a little bit. All right, so now we have a pretty obvious like line by line. And now we can do a, let's get rid of that and just power it. Blap, 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 blap. So is it random? Is it I wonder what the algorithm is, because we didn't specify one. So how do we figure out how it's determining where to send the traffic? What does the documentation tell us? Virtual host. I don't really care about any of that. Guide, cert manager, XML authorization, migrating to resource limits. I don't care about any of that. Dude, just tell me. So I'll want to look at that. How do I find request rewriting, health checks, rate limiting? Do we have to look at the API reference to figure this out? Right, so here's our type, HTTPProxy spec. We want our routes, conditions, services, authorization policy, retry policy, health check, load balance proxy. This is probably what we want. We might also want to look at the rate limit policy. Here we go. Okay, so by default, it's using round robin. Interesting. Yeah, I'm not sure this is, I mean, this is not what I think of when I think round robin. But that's fine. Let's just pretend it's round robin. What about this? So let's have a quick look. Hopefully I muted myself in time so I didn't cough in your ears. So we can set load balancer policy. So let's come to our doc. So let's do a get HTTP proxies, get web-o YAML. I wonder if it will actually tell us here's my spec. Oh, I thought it might interpolate what the default is there. Never mind. I thought that might be an easy way to figure it out. So let's pop back to our docs. We're going to do this the old-fashioned way. Extension service spec route. Load balancer policy on under route. I think here. Strategy. And let's try setting that. Bad indentation. Probably needs to go there. So let's try and apply that. Okay. So now let's do our get. So there's our strategy is there. So I wonder if that's going to change our maybe. Can I do something like 1 in 10? Let's have a look at our docs. All right, let's pop back and look at rate limits. So rate limiting, determining a local rate limit, blah, 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 blah. Okay, so requests is 100 per hour. So this comes under, yeah, I can do it for the route. Good. So this is part of the route. Oh, and I can customize the response. Oh, I wonder if I can do, I was going to say, I wonder if I can do a 301 and redirect it on a rate limit, but I guess not. Oh, and you can add responses. All right, here we go. 20 requests a minute. So let's apply this. Let's grab that whole thing. That looks like an interesting one to roll with. Let's get rid of the load balancer policy for now. And that needs to be tabbed in 1. That looks right. 20 per minute. So that should hit with that while loop. So if we do the apply, wow. Must be of type string. Boolean. Is that what's happening here? Right. This is incorrect. Now, is there a button? Oh, I like it when docs have a button to say fix this and takes you straight to like a Git editor. But looks like so let's validate that it's now working, and then we might come back and do a pull request there. So first of all, let's do our get and make sure that that is now set our rate limit policy, and our the other thing we had set is gone. So I think this means if we do the curl, after 20 requests, it should start failing. So let's do that. I don't know. It's about 1 a second, right? So after about 20 seconds, we should start seeing it fail. I am not seeing a failure. Let's get rid of the grep. There's no extra headers being added. All right, so I guess we need to read more about how rate limiting works. Individual routes or entire virtual hosts. Per Envoy pod. And then global rate limiting. Okay. So I'm seeing something here. We have k get k -n project contour get pods. So we have 3 Envoy pods. And so what that rule is actually doing is saying each one can handle 20 requests a minute. So let's switch that to 2 requests a minute. And then let's reapply k. And then let's rerun our thing. So we should very quickly start failing. There we go. So we got 1, 2, 3, 4, 5, 6 replies. And then it started failing. So if we get rid of that grep, look at this. Rate limited is true. So that is the rate limiting absolutely working. And that's pretty cool. 429, too many requests. That's what we would expect from a rate limit. Now, how do I do like a weighted load balance? I want to send like 10% of requests to Nginx. How would we do that? Request rewriting, client authorization, TLS delegation, deployment options. All right, let's pop right back to here. I don't want local rate limiting. Dynamic request headers. Oh, cool. So I could do that. Request hash. Didn't it say something about doing load balancing per request routing? Aha, wait, 10 and 90. All right. So we can grab that. And let's pop this back up to 100. And then let's set weight is 10, weight is 10, set weight is 90. So that should mean that 9 out of 10 times we hit Nginx. Let's just check that there was nothing else we need to set. Weight shifting, weights, blah, blah, blah. So why don't we do this, pop this, and do that. And we'll call that rate. And we'll call that rate. Get rid of the weights. And we will set this to be 2. Right, so we now have rate dot. We'll do rate limiting. And then we'll have web. We'll do regular. So let's just do a third one here, which is web. And then we'll call this weighted. Wait. We don't want rate limiting there. And then up here, we don't want weights. And we don't want rate limits, right? So we have 3 HTTPProxy services, all with a different host name. One which will just round robin, one which will round robin but have a rate limit, and the other that will have a weighted on the back ends. So let's go ahead and do that. K apply -f HTTP proxy. That's the three of them popped in. And so now let's just make sure we can do curl web.zip.io. Right. Let's go back to our while loop. Right. Pop that. Right, so that's switching between Nginx and Apache. Let's pop our grep back in there. Grep. So somewhat round robin-ish, I guess. Oh, I wonder if it's doing round robin per endpoint. And so because it's shuffled per not endpoint, but per envoy pod, and we've got 3 envoy pods. So there's probably 3 pods, 3 envoys, each doing round robin. But then the load balancer that's sitting in Amazon is randomly giving out to those. And that's why this isn't a precise round robin. And I bet the longer it sits here, the closer it gets to being consistent, maybe? I don't know. Anyway, that's our web. We've already seen that. So now let's just check that rate limiting is still working. So this should give us 6 responses and then start failing. And it does. Now we'll go ahead and look at that third option, which is weighted, which should give us almost all Nginx with one but again, this is probably going to be per envoy. So that's not going to be 10% of all traffic ever, although that does look pretty consistent. So maybe Envoy is coordinating that. Is that, yeah, see, that's not fully consistent. So I'm going to guess that each, again, this is a local setting to Envoy, not a global setting to Envoy. So I think that's why we're seeing some consistency here, because we have 3 Envoy nodes, and they're not aware of each other's and what each other is doing. So I think that's all of these settings seem to be local at this point to the given Envoy pod. But still, I mean, that's working pretty well. So that, I feel like this might even be a good place to finish up. We do have to have a look at, let's see if we can find the doc here for this. Was it here? We had a true. Right, this fella right here. So let's have a look for the Git repo. It's just there. That's what I wanted. So we're looking for docs config rate limiting. Docs. Version release documents. Wait, no, I want to edit the docs. Where do I edit the doc? Code of conduct, Design. These are all design docs, yeah. /docs to /site. There we go. All right, this looks better. So docs 1.12. Config. So rate limiting. Right there. All right. Well, I'm not going to make you sit around while I do a GitHub pull request, but I will update this because that needed to be in quotes. Otherwise, I think this is a good place to end. So if you joined me, thank you so much. If you're watching this later on YouTube, thank you for watching this there. And I will see you again next week or whenever we happen to run into each other. Bye-bye.